So let's look at this stuff here. We'll put this generator back together. I'm going to do a couple tests here, actually 3 tests on this armature. The 3 checks we're going to check are open circuit in the windings, and we'll just go from commutator to commutator all the way around to verify that there's continuity between them. We're going to test between the commutator and either here or there somewhere and just make sure we don't have any windings grounded out, and then we'll also verify with the growler, with it running, any short circuited windings. This will turn on and it will create a magnetic field, and we will use a thin piece of metal, which this works here, a ruler, and if there's any shorts in this, this will vibrate rapidly. So let's give it a whirl. I'm going to turn this on. Might not be able to hear much, but it'll make a little bit of noise. So the first one we will do is check for continuity between them. And I'm going to use the light feature on this one. So that tested good. Now we're going to check for any shorts, or excuse me, any grounded out windings. So I will just test across the commutator to the case. We'll go to the shaft in here just to verify everything. So that's a good test. And now we'll do the metal band here and rotate it and see if we get any vibration, any oscillation on the ruler. The 3 checks I did, make sure there's no open windings, no grounded windings, and then also any short circuit windings. So as far as I can tell, this armature is good to go. So we'll move this off to the side. On this old growler, 3rd prong pushes out of the way. Don't see that anymore. Pretty unique blade latch, they call it. I don't know if you can see that. Interesting. So now the other test I'm going to do is check the field windings on this, and I'm going to step back and show you the pictures, but these field windings in this are in pretty tough shape. The cloth was starting to deteriorate, so I decided to pull the cloth off and rewind them. So it may look a little different. It's not the original cloth, but it's a cloth material that has some adhesive on it. It's from 3M. It's high temperature stuff. Works pretty good for this application. I've used it before on other ones and seems to work. It may not be the original way, but it works for this application. So I'm going to test the windings. I'm just going to check that I have no shorts between the A terminal here, even though it's not hooked up to anything, but I'm just going to verify that that's all good. And we just have it testing on the ohmmeter, and I got nothing. And I'm just going to make sure that the wire works all the way through. Yep, we're good there. And then I'm going to test the field windings, the F terminal to the case, just to make sure I'm not grounded out anywhere. So that's good. Now the next one I'm going to do is check the ohms in the field windings, and I'm just going to go on the F terminal right there to the windings on the other side. And from what I can tell, I don't know if you can see that, field windings we have 7.2 ohms, 7273 of resistance across the field windings. So we can verify that in the book by going here. So we verify our generator. It's a 1107, excuse me, 1101756. We'll go right here to this one. I think you can see that 110756 is right there. It's 12 volt, and that should be our field amps. But we measured it in ohms. So a simple calculation will tell us what our amps would draw. So we'll take 12 volts divided by 7.2 ohms, and we come up with 1.666. And back to this scale here, the 756. And here we go, 1.6 to 1.6. So the field windings look to be in good shape. So with those tests out of the way, we know that the field windings are good, they're not shorted out. Our armature is good, there's no shorts in there. Commutator is not grounded out. Everything is good. So with all that, we can put it together. So I did put the brush assembly somewhat together. There's already a little grease in there. This one is a little different setup for John Deere's. I haven't seen anything like this, just because of the case is different. So kind of unique. Not quite following that one. I think I talked about it in the teardown part of it, but just a little different. But we'll use it. Seems to work. So I did put it all back together already. It's pretty straightforward. Just the bracket that holds the two main brushes, and then the other one for the third brush, which on these is adjustable. You can rotate back and forth. So if you can tell on here, the two brushes are kind of held out of the way. That's what's nice about these, is you can actually just overset, or not really over center it, but just push it back a little bit. Not going to get too carried away, just a little bit for now. I'll just put it in there, just like so. You have a washer there. I'm going to set it on here. Kind of gives it a little space to stack everything together, because you can see it protrudes out. And with that, then you can just push the brushes in. I think push this out of the way a little bit, but since they're held out of the way, nothing's touching them, but you can just push them in one at a time. And it should be good to go. And there we go. So we have that all set up. I'll just put these wires up out of the way so we can get to them in a little bit. One's going to be for the battery voltage, and the other one will be for field windings. So we'll just stack it on there, and there is a alignment pin we'll line everything up with. The trick is get all the wires out of the way. So we should be good, I think. Where's that wire? Yeah, clear there. We're all clear. We can adjust that in a little bit. We'll put that there. Now the next step would be to put the drive end housing, bearing housing together. So it does have a felt seal. And goes in first. There's a little deflector that goes in there next. And the bearing. So I did grease it up already. I'm just going to slide it right in. Yep. And then the plate that holds everything in. I did cut some gaskets. And we'll just go back together. We'll give it the old spin test. So it looks pretty good. So that's pretty much all ready to go together. Pretty simple. The next thing would be to put this washer in there, spacer. Same thing on this one. It's got an alignment dowel pin. And we'll just go back together. Pretty simple on that. Put it on the stand here, and I just screwed up. Get everything lined back up. Kind of holds it in place, and we'll get the through bolts put in. We'll just snug them out. So everything's good there. So on this one there's 3 brushes. The main brush that comes from your battery for charging purposes, and then to create a magnetic field, it pulls voltage from a 3rd brush for your field windings. A little tape in the way there. And let me get my bearings on where everything's at here. That's the ground. This would be your battery one. Then over here would be your field windings. Alright, so the first one I'll put on is the 3rd brush, and that would be this guy right here. And we'll see if we can get all this stacked together. Okay, so that is in there. The 3rd brush, just going to make sure it's not touching anything. Kind of twist it up out of the way, and then this one is the adjustable one for voltage. I can get it to move. Yeah, there we go. And then we will do the last one here, the main brush. And we'll get the last one put in, maybe. Alright, so everything's put back together here on the windings, all the wiring side. From what I can tell, I think we're good. Might have to make some adjustments here and there, but for now, I'll leave it. So that's put together. I'll stand it up on the end here to do the pulley and all that stuff. So there's a bushing that goes in there. It's sitting a little low right now, but I think we can make that work. And I'll drop the key in. detail on there. It's a little bit angled. The key, I'm going to do that to make it start a little easier. Let's get everything lined up on the pulley. And then once we have it started, I will go in and adjust the key. This looks like a proper tool, but it works. I didn't need much with it. Just needed a little tap and I'm good to go. And then we'll go together with this. We'll verify that everything is good. Yep, little end thrust. Should be good. Now we'll just flip it over and put this together. So this does have a wick in there. This little guy, I don't have a new one, but I'm going to reuse this one. So the proper way to do this is actually pull this plug out. There's a little, like a freeze plug, and then it just slides down in. But I'm going to leave that in, and I'm going to weasel this in through the bottom. Sometimes it goes easily, sometimes it doesn't, but we'll find out. Alright, so that's in there. Hopefully we can see in there. Yeah, there's the wick. I'll get a flashlight. I don't know if that helps or not. That little wick is right in there. So as you oil this, it'll pool in the bottom. And as it rotates, it'll pull that up and lubricate this bushing on the non-drive end. So that's in. And we'll just put the end plate on. I did make another gasket for this end. So the last piece would be to put this on here. We're just going to demonstrate the third brush adjustment on this one. Since this is an open house, open-ended end on here, you can adjust your third brush. And on this particular setup, that's how you can adjust your generator output. Closest to the main brush to pick up more voltage to your field windings, and create a stronger magnetic field, which in turn will create more output. If you move it farther away from the main brush, the voltage will be lower, which will create a lower magnetic field, and in return creates lower output. That's what's kind of unique about this one. You can probably adjust it on the fly. And the last piece is the band. I did just cut a piece of gasket material for it. The old one is not in very good shape. And the last thing to put on there is a cutout relay. Right. So that's how you build a generator for a John Deere tractor.